Welcome back. You have come back for some more algebra. Are you crazy? Well, this week we're going to cover the slope of a line. Okay? Now, I know it's been a long time, it's been a week, and you've probably forgotten everything you learned about last time. Before we cover slope of a line, let's take a look at lines themselves. That's what we covered last time. Let's see. The rectangular coordinate system, we remember, was a way to plot points. For instance, we could plot the point 4, 5, which has as its x-coordinate a 4, and as its y-coordinate a 5. Remember that the x comes first in this ordered pair, okay? So we're going to graph that first. Let's take a look. We'll move from the origin over 4, that's the x part, and then don't put a dot yet, and then from there up 5. So the point 4, 5 will go in that position. It takes two numbers to make a position for a point. Let's look a couple more just in case. Okay? The point 5, 0. Now 0 can be involved. Remember that? We can still do the same thing. We will do the x. We'll move over 5 from the origin. And then up how much? Up none. Okay? Up none. And the point will go right there. Okay? What about negatives? Negatives can be involved here. Let's plot the point -5, -3. Okay, well, let's see. The x part is -5. So in this case, we'll go 5 backwards, okay, for the x, or to the left, I should say, and 3 down for the y. Okay, and then our point will go there. Okay, now we'll take points. Let's go a little bit further. Remember that points, all the points that fit into an equation could be graphed, and they line up. Pretty cool. Okay? Let's graph this equation. Now the one thing, if there was only one thing I asked you to remember to graph this line, it was, we wanted to find several points, at least some, to graph this line. What are we going to do first? Especially when you get baffled and you forget anything. You got that right, Buford. Let's do that first. I'm going to, let's see, I'm going to subtract 4x from both sides to get y by itself. That'll cancel out. Okay, and then I'm going to, who else is keeping y from being by himself? The 2. So what's the 2 doing? Multiplying, so I'll do the opposite. I'll divide. Do it to both sides and do it to everybody to be fair. Okay, so I'll get y, in this case, nicely by himself, will be, or herself, will equal 4 minus 2x. Now it's going to be easy to put some points in. Let's put in the easiest points that I could think of, or I should say put points in, to put in x's. Okay, let's see. I'm going to put in 0, and if I put in 0 instead of x, what will this recipe for y give me? Well, 4 minus 2 times nothing, or 4 minus nothing, it's going to give me 4. There's one point, the point 0, 4, over none and up 4. Okay, what's another easy thing I can put in? Let's put in 1, the next easiest thing, okay? Let's see. 4 minus 2 times 1, I'm putting it in for x. 2 times 1 is 2, so 4 minus 2 will be 2. And there's our second point, over 1 and up 2. Now actually, we already know where the line is, but you may remember from last time, I'm going to have you do 3 points, just in case, because you know if they line up, you know you're hunky-dinky. Okay, let's take a look. Let's do the point. No, not -87. Make it easy on yourself, okay? Let's make it easy on ourselves. We're going to do 2. Let's see. If I put in 2, 4 minus 2 times 2, or 4 minus 4 is nothing, so y in this case is 0. Go over 2 and up none, and you know you're hunky-dinky. They line up, and there's your line, okay? We did one more type of graphing last time, and that was inequalities. Let's do one of those just in case you've completely forgotten everything. Okay, this one, what should we do first? We need to find some points. No! Very good. We always start this whole chapter solving for y, basically. Okay, let's see. What do we need to do? I'm going to add 2x to both sides, and we'll divide by 3. Now remember one thing, and I didn't have it in this example. If you divided by a negative number, you'll have to switch the sign, but I didn't include it here. Okay? So we've got y by itself, and we're going to pretend in this inequality that we have an equality. Okay? That it's an equals. And let's put in some nice points. Is 0, 1, and 2 nice points in this case? You may remember from last time, whenever I have a fraction, especially a fraction with the x, it's going to make life a lot easier to put in multiples. And I'm saying, oh, I always put in multiples of 3. No, put in multiples of whatever the fraction's denominator is, and it'll cancel out, because we are all allergic to fractions, we know. Okay, so let's put in multiples of 3 and see what happens. I'm going to put in 0, 3, and negative 3. You would probably put in 0 and 3 and 6. I'm putting in negative 3 because it fits on this graph. Okay? Okay, let's see. If I put in 0, that's easy. That whole term cancels out. 2 times nothing, and I get y is 1. So there's 1 point. If I put in 3, the 3's are going to cancel out here, and I'll get 1 plus 2, which is 3. So I get a point 3, 3. Let's graph that. Over 3 and up 3. If I put in negative 3, the 3's will cancel, but the negative won't. Okay, so I'll have 1 plus negative 2, which equals, I promise you, negative 1. So I get the point negative 3, negative 1. Just as review, that means we'll go back 3 and down 1. It'll end up right here. And now they line up, but remember, we're doing an inequality problem here. So we've got another couple of steps to do. Okay, before we actually draw the line, you have to decide, is this going to be a solid line or a dotted line? Okay, what decides that? If it's an or equal to situation, like greater than or equal to or less than or equal to, it's going to be solid. If it's less than or if it's greater than, we don't want to include the line, so it's a dotted line. Well, in this case, it's going to be a solid line, okay, because it was an or equal to. Now we have to decide to shade above or below. Well, isn't it nice that we solved for y? Okay, we don't need to do any test points. Y is less. Where does y get less? Above or below? Below. Hi, Mom. And that's your answer for an inequality. It's going to be a shade graph. Okay, ding-a-ling. I think we're in good shape. Oh, that means it's time for the new stuff. Okay, what are we covering today? The slope of these alleged lines. Okay, what do you mean by slope? I think a lot of you know. Certainly you mountain climbers and skiers know all about slope. Let's take a look, though. The slope of a line. Well, if you look at a line the way you read, from left to right, and let's do that. It's natural. Let's read from left to right. If I look at this line, okay, well, if I was walking on that line, I'd be walking uphill. So it shouldn't surprise you that that's going to be a positive slope. I'm walking up. Okay? Take a look at this bad boy. From left to right now, I'm going downhill as I walk or as I roll on this. So it shouldn't surprise you that's going to be a negative slope. What about this one? If you walk on it, well, it's flat. Numerically, that shouldn't surprise you that that's going to have a 0 slope. Okay? Now, there's only one other possibility, really, and that's a line that looks like this. Now, if you tried to walk or climb on this, what would happen? Well, you would fall. And you would fall how far? Considering that that line is infinite, you would fall past purgatory all the way to HE double toothpicks, and probably further, because it goes on forever. Okay? So it shouldn't surprise you that the slope of this line is infinite, or we say undefined. I'll be showing you why it's undefined, because we really don't understand what infinite means. Okay? Okay, well, what about getting actual numbers? I understand positive, negative, 0, that kind of thing. Actually getting numbers. Well, if you look at this line, the uphill, it shouldn't surprise you, of course, that it's a positive number. This line is also a positive number, but since it's steeper, it's going to be a larger positive number. The steeper you are, the higher the number of the slope. We talk about things that go downhill. There'll be negative numbers. This one happens to be -1/2. Okay? This one's even steeper. Okay, this is the difficult hill. This is the one I fell down a couple of days ago. That should be a more negative number, or if you would, a smaller number. Okay, and that one actually is -3. I'll show you how we got these numbers, but I just want you to see that it makes some sense here. Okay? Well, what is the actual number? How do we get the number that measures slope? Well, by definition, if you pick any 2 points, now it has to work for any 2 points, the slope of a line is defined as, between any 2 points, how much you went up to get from one point to the other, how much you went up or down, which is called the rise, relative to how much you went over, which is called the run. So you often hear the term, the slope is rise over run. Okay, then it's a fraction, which we can reduce. We may have to reduce. Okay, let's take a look. At this case, it's going to be, the slope is going to be 3 over 1, because as you can see, I went from this point, to get to this point, I went up 1, 2, 3. That was my rise, and I went over 1. So the slope is 3 over 1. Okay? This one, to go from one point to the other, I'm going to go up 1 and over 2. So the rise is 1 and the run is 2, so it shouldn't surprise you that the slope of this line isn't as steep, it's 1/2. Okay? Now how do I know which points to pick? Well, the nice thing is it shouldn't matter. It doesn't matter which points you pick. Okay? I pick this point and this point. Now the only reason I pick them is because they're at corners and they're easier. So we're always going to obviously make things easy on ourselves if we can. Okay, let's look at these 2 points. To get from the first point to the second point, I would have to go down 2 spaces and over 3. So my rise in this case is actually a fall, and my run is a positive number 3. So rise over run, or fall over run in this case, would be -2/3. Now wait a minute. What if I picked these 2 points? Dagnabbit, it shouldn't matter. Okay, I don't want you to have to worry. You have to pick the right points. Doesn't matter. Okay, let's take a look at those 2 points. Well, that's to get from that point to the other point. I'm going to go down 4. Wait a minute, it's starting to smell different here. Down 4 and over 6. So my slope's going to be -4 over 6. But wait! If you reduce -4 over 6, what do we get? -2 over 3. There's your buddy. So you're going to get the same answer. You should get the same answer no matter which 2 points you pick. And actually, to save ourselves from having to draw this picture, there's a formula we can use if I give you 2 points. Okay? Let's take a look at this line here. If I call this point 1, the point 0, 2, and I'm just picking them arbitrarily, and this point 2, the point 3, 4. Okay? I remember what I was doing visually. I was measuring how much I went up relative to how much I went over. Well, the amount you went up, as you can see, is 2. How did you know it was 2? What did you visually do? You know what you did? You don't even know you did it. You went y2 minus y1. What do you mean y2 minus 1? The y part of the second point minus the y part of the first point. It's starting to sound hard. Hang in there. Okay? Well, let's see. The y part of the second point is 4, isn't it? Minus the y part of the first point is 2. So you visually went 4 spaces minus 2 spaces. I hope you kind of did. And that was your rise. The run, you visually actually went the x part of the second point minus the x part of the first point. The x part of the second point is 3. The x part of the first point is 0. So you kind of went 3 minus 0, okay, in your head. 4 minus 2 is the 2 spaces, and 3 minus 0, of course, is 3. So the slope of this, without even looking at the line, you could have done it using this formula and gotten 2/3. This magic formula, y2 minus y1 over x2 minus x1, you're going to have to memorize, okay? Or you're going to have to draw all this, which is a pain. Okay, let's do another one. we'll start with, in this case, I'm going to do the same line, but I'm going to switch the points. So that, what if you made, the 3,4.1 and the 0,2.2? I should get the same answer, shouldn't I? Let's do it. This case, it looks like the rise is a fall. The y part of the second point minus the y part of the first point should work. Let's see, the y part of the second point is 2 in this case, because we switched points. And the y part of the first point is 4. Well, we're putting them in, just like the formula says. And the run will be calculated by the difference in the x values of the points. The x part of the second point minus the x part of the first point. The x part of the second point is 0, and the x part of the first point is 3. This sure isn't looking like 2/3, is it? Well, wait a minute. 2 minus 4 is negative 2. It's not looking good. 0 minus 3 is negative 3. But wait a minute, you have to reduce. And if you reduce negative 2/3, you get 2/3. So pretty cool. Okay? Let's use the same line and still use completely different points. I'm going to use farther away points. In this case, point 1 will be negative 3, 0, back 3 and up none. Same line though. And we'll use our same point there, 3, 4 for point 2. Shouldn't matter, should it? Let's use our formula. Our rise or fall, if you would. Once again, y2 minus y1. In this case, is going to be the y part of the second point, which is 4, minus the y part of the first point, which is 0, over the x part of the second point minus the x part of the first point. The x part of the second point is 3 in this case, and the x part of the first point is negative 3. Now don't get nervous on the negatives with me. Let's see if we can calculate what this is. Should come out to 2/3, same line. Well, let's see. 4 minus 0 is 4. 3 minus negative 3. Get your calculator out if you need to. You know what I do? When I see two negatives in a row, I turn them into a positive, because the negative of a negative is a positive. Okay? So that's how I'm going to calculate. 3 minus negative 3 is 6. And guess what? Hi, Mom. If you reduce 4/6, ding-a-ling, you still get 2/3. So as long as you do your calculations, the same, doesn't matter which 2 points, as long as you do them correctly, it's not going to matter. Nothing's going to matter. Okay? Of course, you'll have to memorize that formula. Okay? Let's take a look at a crazy one. There are a couple crazy ones. You say, oh, it's not going to work for this one. Yes, it is. Okay? We know the answer to this already, but just to prove that it works. Okay, we're going to use these 2 points. I just picked them arbitrarily from this line. And let's see if we can calculate the slope of this. y2 minus y1 in this case, the y part of the second point, as you can see, is 1. And coincidentally, the y part of the first point is 1. Okay? What about the x part here? The x part of the second point is 6, and the x part of the first point, in this case, is 2. Let's calculate this. 1 minus 1 is 0, and 6 minus 2 is 4. Don't get all choked up. What is 0 over 4? What is 0 over anything? 0. And you knew the slope of this was 0, didn't you? So, shouldn't be surprised. Let's look at one more crazy one. This one. Okay, let's see. We're going to arbitrarily pick any points. I'm picking them on corners so they come out even. Okay, but it should work, as I said, for any points. Okay, we've got a first point and a second point. My rise is actually a fall. Okay, or if I go from point 2 to point 1 or point 1 to point 2, it's not going to matter as long as I'm consistent, if you would. Okay, let's see. The y part of the second point minus the y part of the first point is going to be, in this case, go a little bit faster, 4 minus 1. Okay, do you see that the y part of the second point is 4 and the y part of the first point is 1? We have to put that over. We're consistent now. 2 minus 1, if you would. The second part minus the first part. Here again, with x, we have to be consistent. second part of, x2 minus x1, we'll get the second part, whew, the second part of the second point is 3, and the x part of the first point is 3. And in this case, it'll actually calculate, it will calculate 2. 4 minus 1 is 3, and 3 minus 3 is 0. Now, what is 3 over 0? What is anything over 0? Well, it's undefined. That's why a line that looks like this, a vertical line, has a slope that is undefined, because no matter what 2 points you pick, you would get some number over 0. Okay? And it actually makes sense if you think about it. If you tried to walk on that line, you would fall infinitely. Okay? So there's another reason why it has an infinite really isn't defined, so you would have an undefined slope if you would. Okay? Okay, well, if we really understand what we're doing, could you draw the graph of a line containing the point 0, 2 with a slope of minus 1 over 2? Don't get all choked up on me here. Hold on. We get the graph. We know it contains the point 0, 2. So let's graph that first. Now, how is the slope of minus 1 over 2 going to help me? Remember, the definition of a slope means between any 2 points, one of which we already have, it's going to go rise over run of minus 1 over 2 in this case. Well, it sounds like it's going to be a fall of minus 1 and a run of 2. So let's start at our point, 0, 2, and do a fall of 1 and a run of 2, and we'll have to get to, by definition of slope, another point on that line. There it is. And once I have 2 points, ding-a-ling, I've got the line. Okay? So that's another use of the slope definition. Thank you. How about this one, now that you know what to do? It's a little bit different. We have the point 1, 1, and this time has a slope of 3. Well, there's the point 1, 1. But the slope of 3, I remember that slope is rise over run, but 3 is only one number. But remember, 3 could be written 3 over 1. Any number is itself over 1. So I could have a rise of 3 over 1, and a run of 1. So you can throw 1 around like cheap meat, remember. Okay? And there's my other point, and bam, there's your line. Okay? So it gets started off a little bit tricky, but it's not so bad. That was a tough one. Okay? Let's take a look at that. What do you think the slope of this line is? I'm not giving you any numbers, any points, or anything. Let's pick some strategic points, and we can measure them. Okay? I'm going to pick that one. I'm even telling you what that point is, and that point. Notice I have them at corners. Okay? What would the slope be if you really understand the definition of slope? What's the rise and what's the run? Well, to go from the leftmost point, if you would, to the rightmost point, I went down 1 space and over 3. So it shouldn't surprise you that the slope of this line, of course, is minus 1 over 3. Let's do one more like that. The slope of this line, let's pick strategic points. That one's at a corner. There's one at a corner. Let's see, rise over run. How much did I go up relative to how much did I go over? So the slope's going to be 2 over 1 in this case. Okay? What if we use different points? You know, of course, that it doesn't matter, but let's use different points. We had 2 over 1 in the last one. I don't see any 2 here. Let's see. We're going to go up 4. That's different. And over 2. But remember, if we take that and reduce it, 4 over 2, you have to reduce to get the final answer. We'll still get the same answer. Pretty cool. Okay? Almost makes sense. Okay, woo, what is the slope of this one? Well, what can we do to find the slope? Well, what if we get 2 points? 2 easy points, if you would. Okay? My easiest points are 0. I'm going to put in a 0 and put in a 1. Put in a 0, I get negative 1. Okay, if I put in a 1 for x now, I've done this before. 2 times 1 minus 1 is going to be 1, 1. So I have 2 points. So this extra step of putting in the whatever you want, as I say, it doesn't matter what points you use, so it shouldn't matter what x you put in. I just put in the easiest 2 I knew. Okay, so I have these 2 points. Now, once I have 2 points, how do I figure out the slope? I'm going to use that formula, sometimes called actually the point slope formula. y2 minus y1 over x2 minus x1. Okay, let's see. In this case, we'll call that point 1 and this point 2. So y2 minus y1 is 1 minus negative 1, right? The y part of the second point minus the y part of the first point is 1 minus negative 1. The x2 minus x1 part is going to be 1 minus 0 because the x part of the second point is 1 and the x part of the first point is 0. Let's do our calculation here. Remember that if you're allergic to negatives, 2 negatives in a row are going to produce a positive. So that's going to give me a 2. And 1 minus 0, my mother can do that, is simply 1. So the slope of this line comes out to 2. What about this bad boy? The slope of this one? Well, I'm going to break all the rules here, okay? I'm leading up to something. The slope of this one, once again, I want to find 2 easy points. But I'm going to break a rule that I have used up to this point. Hold on. 2 easy points. I'm going to put in 0 for x. And now I'm going to solve. And 3y equals 9. I've got to solve, divide by 3, and y is going to be 3. There's 1 point. Now, what's another way to find an easy point? Well, I'm going to put in a 0 for y in this case. Okay, so I'll put in a 0 for y and figure out what x is. Okay, let's see. See how 0 makes it easy. Divide by 2, and x in this case will be 9/2. Okay, that's okay. I can deal with this. So let me put these in to the formula. y2 minus y1 over x2 minus x1. Let's see. That being 0.1 and this being 0.2. y2 minus y1 is 0 minus 3. And x2 minus x1 is 9/2 minus 0. Don't worry about fractions. We'll work this out. Okay, 0 minus 3 is a negative 3, and 9/2 minus 0. These zeros are helping us out here, aren't they? 9/2 minus 0 is 9/2. Now, how do you divide negative 3 by a fraction 9/2? Remember how to divide fractions? You actually multiply the opposite, don't you? So negative 3, known downtown on Friday nights as negative 3 over 1, times the reciprocal of 9/2, 2/9, is going to be minus 6/9. What are we forgetting to do here? We've got to reduce. So in this case, for this equation, the slope is minus 2/3. But you didn't like that, did you? That was hard. Okay, what did I forget to do? What did I forget to do that I always preach to do? Okay, we didn't have to solve for y, but it sure is going to make life easier if we solve for y. Now, the next section of this class, you're going to see yet another reason, and the killer reason, to solve for y. Okay, so remember, from the idiot way I did this one, that you could probably want to solve for y all the time. Okay, let's take a look at the slope-intercept form of an equation. Sounds hard. Slope-intercept. We know what slope is. What's the intercept? Well, once again, look at our rectangular coordinate system. We have the x-axis here. There's 0. Positive x are the positive numbers. Negative x are the negative numbers from that direction. Of course, we have the y-axis, plus and minus. Okay? Now, if we put a line on there, this line is already solved for y. Pretty neat. I want you to note something about this line. By definition, it's, if you would, y-intercept is where the line hits the y-axis. Do you see where it's hitting the y-axis? It's hitting it at minus 1. It's crossing over the y-axis. So that's why its y-intercept, if you would, is called, or in this case, is minus 1. Let's look at a couple more. This one, And I promise that's the line, y equals minus 3x plus 4. Where is it hitting the y-axis? Well, it's hitting it right at 4. Okay? It doesn't have to hit it at an even number, but in this case it happens to. So its y-intercept, in this case, is 4. Are you starting to see a pattern? Well, keep looking. We'll give you a couple more chances. Okay? The y-intercept of this line, we're back to the other one, is minus 1. Okay? You know why it's minus 1? You know why the y-intercept is? Because where does it hit? What is the, if you would, the x-coordinate of the point here? What is the x-coordinate of that point when it hits the y-axis? What will it always be? It'll always hit it when x is 0. So another way to find this, without even looking, would be to put a 0 in for x. And you can see, in this case, the y-intercept is minus 1. There it is. At the point 0, where it's x, and minus 1, we knew. We're just restating it for y. Starting to notice something about that equation? Hold on. Let's look at another one, just in case. The y-intercept of this one was 4. Why is the y-intercept 4? In other words, it's hitting the y-intercept at 4. That's one reason. Okay? But what is the x value when it hits the y-intercept? Okay? Well, it's 0. And if we put in 0 for x, what should we get? And we do, minus 3 times 0 plus 4, we do get 4. Okay? So, son of a gun, the y-intercept is sickeningly simple, I think. I hope. Okay? Or you notice anything about this equation, its y-intercept being 4? Well, guess what? That's 4 minus 3. Where's that coming from? That's going to be the slope. The slope-intercept form of an equation, once you've solved for y, is y equals some number times x plus some other number. Okay? Or you're going to see the general form, y equals mx plus b. Where m, the number in front of the x, will always be the slope, and b, the number sitting by itself, or the constant, will always be the y-intercept. Now don't make this hard, because it's not. Okay? For instance, in this equation, we don't have to do any calculations. What's the slope of this line? 7. The number in front of x is always the slope, and the other number, the number sitting by itself, is the y-intercept. So guess what? We don't even have to graph this bad boy. The y-intercept is 3. Let's look at this one. What's the slope? Oh, I did the y-intercept first. The y-intercept is 7, the number sitting by itself. And the slope is the number sitting in front of the x is minus 2. You can have a negative slope. It's negative 2. Okay, let's see if I can fool you. What's the slope and y-intercept of this one? Okay, now remember, I didn't say it's always the first one, or it's always the second one, or something like that. We said the slope is the number in front of x, and the y-intercept is the number sitting by itself. So if we look at this, the y-intercept in this case is going to be minus 2. That's the number sitting by itself. And 6 is going to be the slope. Doesn't matter what order they come in. It's who they're standing with, if you would. Okay? Okay, here's a little tricky. What's the slope and y-intercept of this? Well, the slope's easy. Okay? Slope is the number in front of x. What is the y-intercept? What is the number sitting by itself? Well, I don't see a number. Well, there's got to be a number sitting by itself. So we make a number sitting by itself. Okay? Well, the y-intercept is 0. And if you graph that, I promise you, the y-intercept would be 0. What about this one? Y equals 3. Well, the number sitting by itself is 3. So I know the y-intercept. What would be the slope? What would be the number with x? Well, we don't have an x. Okay? If we don't have an x, we kind of have a number of 0. So you could rewrite this as 3 plus none x, which means the slope is 0. Okay? You're going to have a slope of 0. In fact, here's a picture. That's the equation, y equals 3. And as you can see, the y-intercept, I hope you can see, The y-intercept is 3. It's crossing at 3. And it is flat as flat can be. So, son of a gun, it makes sense. Okay? What is the slope and y-intercept of this? Wait a minute. None of this works unless you get it in slope-intercept form. You see why I've been telling you to solve for y? Because slope-intercept form means y is by itself. So we'll always begin, as we did before, by solving for y. Let's do that here. Subtract a 6x from both sides. Okay, what else do we have to do? Who's the other troublemaker? 2. 2's multiplying y, so we have to divide by 2. Okay, this one comes out sweet and neat. Well now, bang! The slope is the number in front of x, in this case is -3, and the y-intercept is the number by itself, 4. Not too bad as long as you remember to solve for y. What do we got here? Give the equation of a line with slope 5 and y-intercept -3. You can do it right away. We know that it's y equals something times x plus something, where the number in front of x, they sometimes say m, I don't know why they don't say s, is the slope. And they gave me the slope in this problem, didn't they? What did they say? The slope is 5 and the y-intercept is -3, so just put them in. Okay? The answer to this question, you just do it right away. Y equals 5x, the slope is 5, -3. Bam! That's it. What's the equation of a line with slope and y-intercept? Well, it's very simple. Remember, y equals mx plus b. It's going to be y, using that general equation, y equals x plus. Just fill them in. You should memorize this equation, though. Okay? It's another thing to remember. The slope-intercept form, y equals mx plus b, where m is the slope, the number with x, and b is the y-intercept. Okay? Let's try another one. It's a different way of asking this. Give the equation of a line with a slope of 2 containing the point 1,5. Now that means the point 1,5 fits in. Okay? The first part is easy. Since y equals mx plus b, we're going to take that 2 and put it in the slope place. So y equals 2x plus, now all we have to do is figure out what the b is, or what the y-intercept, and we'll have the general equation. But we have another hint, that this point 1,5 fits. So let's plug it in. Remember that 1 goes in for the x, and 5 goes in for the y, and see if we can solve, if you would, for b. Well, 2 times 1 is 2, so if 5 equals 2 plus b, if we subtract 2 from both sides, b must be 3. Now that doesn't answer our question. Our question is, what is the equation? So we have to take that 3, put it back into our general equation, and our general equation for that line will be y equals 2x plus 3, because that's what they asked. Okay? Okay, what else you got for me? Give the equation of a line with a very similar problem. Let's just do a little bit, just another one. Give the equation of a line with slope -3 containing the point -2, 8. Don't let these negatives make you nervous. Okay, so we'll put that -3 right in for the slope. Okay, now all I got to do is figure out what the y-intercept, or b, is. We have this hint that the point -2, 8 fits in. Okay, so let's put in -2 instead of x and 8 instead of y. Let's see, -3 times -2 is 6. So 6 plus what is 8? If you couldn't do it in your head, we'll subtract a 6 from both sides, and bam, b is 2, or the y-intercept is 2. But they asked for an equation, okay? So the general equation of this bad boy is going to be y equals -3x plus 2. Not so bad. It ain't so bad. Okay? Now, let's talk more about slopes. I'm going to try, we're so good at this, we're going to talk 2 lines at the same time. Okay? Consider these 2 lines. I promise you that this is the equation. Y equals 2x plus 5. Apparently, what's the slope of this? The slope is 2, and the y-intercept is 5. And in this case, the green line, the slope is 2, and the y-intercept is -2. What do you note? These two are parallel. It shouldn't surprise you they're parallel because they have the same slope, okay? These two lines, y equals 2x plus 5 and y equals -3x minus 2, they're not parallel, they cross. We say the word intersect, okay? Shouldn't surprise you that they intersect because they have different slopes. One has 2, one has -3. The only other possible thing that can happen with two lines other than being parallel and intersecting, it's kind of a stupid one, but the only other possible thing is that I've got the red line and I got one other line and it's actually the same line. So that's the only other possibility, is that they're the same line, okay? So those are the three possible things that can happen when you have two lines, okay? So if you consider two lines just looking at their equations, wait a minute. We can't tell anything until we solve for y. Let's do the first one. We'll do them one at a time, okay? Subtract a 6x from both sides. Let's see. Divide both sides by 2. Okay, there's that equation. Now, sometimes we are super solve for y machines. I have to do the other one as well. Solving the second equation for y, I'll subtract 12x from both sides and divide by 4. These ones happen to come out kind of nice. Okay, now I can tell without even graphing, I hope you can, looking at that they have the same slope, but different y-intercepts, so they're not the same line. These two bad boys are parallel, okay? And isn't it nice that you know the slope-intercept form? You didn't even have to go to the trouble of graphing these lines. You knew they were parallel, okay? Let's look at another example. Wait a minute. Yeah, we don't even have to say solve for y. Okay, let's solve this one. Divide by 2. And we have y equals 7 minus 3x in that case. In this case, subtracting 12x and dividing by 4, well, this one stares me right in the face. These ones have the same slope and the same y-intercepts. Well, they're the same line, okay? Didn't even have to graph them. I know they're the same line. Let's take one more example. How do these? Well, can't do anything until you solve for y. So in this case, all I have to do is divide by 2, and I get y equals 3x plus 4. Sometimes you don't have to subtract or add something. Okay, in this case, I'll subtract 10x and divide by 4. Do it to everybody. And this one, ooh, that looks like a difficult one. The important thing here, though, is I'm looking at the relationship between the two lines, is that, let's see, they have different slopes. I can stop right there, because as soon as I have different slopes, I don't even care about the y-intercept. If they have different slopes, they're going to meet, because they go on forever. Now, they may meet in heaven, but they're going to meet. Okay? So as soon as they have different slopes, you know they intersect. Okay? Now, there's an intersect, and there's a special way to intersect called perpendicular. Okay? Interestingly enough, perpendicular means they meet at a right angle or at a 90-degree angle. And there's a way to tell whether they're perpendicular or not from the equation. Okay? And that is, of course, we know that they intersect because their slopes are different. If the slope of one is a over b, in general, some number over another number, and the slope of the other is minus b over a, in other words, the minus reciprocal of the other one, that's going to be your clue that not only do they intersect because the slopes are different, but they intersect in a special way. They're perpendicular. Let's see if we can do this. These two lines, do they intersect? Well, their slopes are different, so they intersect. Are they perpendicular? Are they the minus reciprocal of each other? No. Okay, how about this one? Now, this is an example. Certainly they intersect because their slopes are different. are they perpendicular? Well, one's minus 3 over 2, and the other one's positive 2 over 3. There's a perfect example of lines that are perpendicular. See what I mean? Here's another example. Their slopes, the number in front of x, are different. One is 5 over 7, and the other one is minus 7 over 5. So since they're different, they intersect, and since they're the minus reciprocal of each other, they're also perpendicular. A couple more. These ones, are these ones intersect? No, their slopes are the exact same. Both of their slopes are minus 3. So they don't even intersect. They're parallel. Okay? This is interesting. Actually, these two definitely intersect because one has a slope of minus 3 and the other one has a slope of 1/3. So they do intersect. Are they perpendicular? Well, if you consider minus 3 is really, or could be known as, minus 3 over 1. So we have minus 3 over 1 and positive 1 over 3. Kind of tricky, but they are perpendicular. Okay? And last but not least, we've got, this is a very easy one. These ones have completely different y-intercepts, 7 and 9. I'm sorry, completely different slopes, 7 and 9. So they intersect, but they're not perpendicular. Okay? Well, that's enough for today, I bet you. Let's review if we can. How do we measure slope? Well, let's see. Slope is measured by, between any 2 points, the amount you go up or rise relative to the amount you go over or run. It doesn't matter which 2 points. In this case, we went up 3 and over 1, so the slope is 3 over 1. In this case, we went up 1 and over 2, so the slope is 1/2. There's a formula you can use to measure slope. Remember it? You better remember it. But to pick any 2 points, the amount you went up or down can be defined by y2 minus y1, or the y part of the second point minus the y part of the first point. In this case, it's 4 minus 2. Over, and this is part of the formula, the amount you went over calculated from x2 minus x1, which in this case is 3 minus 0. And you can actually calculate them without graphing them. And in this case, we'll have 4 minus 2, 2, and 3 minus nothing, is 3, and the slope will be 2/3. By definition of slope, remember we had problems where we just picked any convenient points and measured the amount we went up over the amount we went over, and in this case the slope was 2. We did some problems where we could draw a graph. They gave us 1 point and then we actually executed the slope. Okay, well, let's see. Well, they give us a point 0, 2, and we're going to execute the slope, a rise or a fall, if you would, of minus 1 and a run of 2. So I'm going to go down from this point they say is on the line. I'm going to go down 1 and over 2, and I'll find another point that's on the line. And once I have another point, I know where that line is. Okay? Remember, of course, and you'll have to memorize, the slope-intercept form of equation, where the number sitting by itself, or b, is the y-intercept, and the number in front of the x is the slope. In this case, then, the y-intercept is 3, and the slope is 7. And this only works if you solve for y. So in this case, to find the slope and the y-intercept, you got it, bub. Let's do that. You've got to begin that way. Subtract a 6x from both sides, divide both sides by 2, and now we can do it. Now that you've solved for y, the slope will be minus 3, and the y-intercept will be 4. Give the equation of a line with slope 5, so we'll put the 5 in for the slope, and y-intercept minus 3. Very simple if you know the slope-intercept form. Give the equation of a line with slope 2, containing the point 1, 5. Well, we'll put the slope in, and then we'll put in our 1, 5, 1 for the x, and 5 for the y, and figure out what the y-intercept, or b, is. Subtracting 2, the y-intercept is 3, so we'll have our general equation. Remember that one, okay? Well, it's time to do your homework, and I should remind you online students that it is time to take your first test, okay? So go to the assessment center and take your tests. Also, remember, if you have any problems or want to review what we've just done, please go to Montgomery College, www.montgomerycollege.edu/algebra. Until next time, do your homework. Bye-bye.
Now, I wanted to leave you with some sort of visual to help you remember one of the more important things of the class. But I'm sorry, all I'm going to do is tell you, solve for y.